Greetings, traveler. I'm the Calculus Cleric, and today we'll be doing infinite series. So the specific question is to find the interval of convergence of the sum of -1 to the nth power multiplied by n over 4 to the nth power multiplied by x to the 2nth power. Okay, so to start off, I want to use the ratio test, and we can disregard the negative ones as anything negative will be factored out as we have to take the absolute value to do the ratio test. And a regular one is just the original. And a of n plus 1 over a of n to the infinite limit. And if we plug infinity into that, it'll be infinity over infinity, so we take L'Hopital's. Derivative of the top, and then derivative of the bottom. And since we want to find out the interval convergence, this series will converge if it is less than 1. Since there's no more n terms, we can get rid of that limit, and then we just solve this out. So our interval convergence is x is greater than -2, but x is less than 2. Okay, now we have to check the actual endpoints to see if there's an equal to sign. So we have to check -2 and 2 by plugging it back into the series. And as we may have noticed, 2 to the 2nth power is really just 4 to the nth power because 2 squared is 4. And so those two cancel out and they will get us 1. It leaves us with the infinite sum of -1 to the nth power multiplied by n. If we take the absolute value of that, that diverges by p series. And the original function without the absolute value, we could take the limit of infinity of a of n on the inside, which gives us an alternating series depending on what is plugged into n. So therefore, by the divergence test, this does not converge as the value did not come out to 0. So when x is equal to -2, in all honesty, it's literally the same thing as -2 squared is just 4 as well. So it'll be the exact same as before, as the above version. So therefore, we know that because they're the same, it will diverge. And so from that, we know that because both sides diverge, therefore x cannot equal to these endpoints. Therefore, this is our interval of convergence.